On October 19th, 2025, a massive chunk of the internet just stopped working. It was all powered by Amazon Web Services' biggest region, US East 1, and it started to fail spectacularly. Now, this wasn't some kind of power outage or a physical attack. It was something way more subtle and honestly kind of more terrifying. It was like a ghost in the machine. And in this explainer, we are going to pull back the curtain and see exactly how the cloud went dark. I mean, really think about that for a second. We rely on these huge invisible systems for literally everything, from streaming our favorite shows to running the most critical business apps on the planet. So what happens when a service that hundreds, maybe thousands of other services depend on just vanishes from the map? That's the exact question we're going to dive into. So this wasn't just one big event. It was a series of cascading failures, a domino effect that unfolded over almost 15 hours. It all kicked off just before midnight with a core database service called DynamoDB. Then, just as the engineers were getting a handle on that, the main compute service, EC2, started to completely fall apart. And after that, the network load balancers followed suit. This timeline here is basically our roadmap for the chaos that's about to unfold. So where did all this chaos begin? You might be picturing some massive, explosive system failure, but the truth is so much smaller. The root cause was a single, tiny bug hiding in an automated system that manages domain names. It was a tiny crack in the foundation that was about to bring down a digital skyscraper. The bug that started it all is a classic in computer science. It's called a race condition. Okay, imagine you have two workers painting a wall. One is supposed to apply the primer, and the other is supposed to put on the final coat of paint. A race condition is like the second worker, the painter, somehow finishing their job before the first one even starts. And then, to make it worse, the first worker comes along and accidentally wipes the freshly painted wall clean. It's all about disastrously bad timing. So to really get what went wrong, we need to look at how this system is supposed to work. DynamoDB has this automated system to update its address on the internet. A planner figures out which servers are healthy and creates a new DNS plan. Then, 3 redundant workers, called enactors, all grab that plan and apply it. This redundancy is key. It's built specifically to prevent this kind of failure from ever happening. But on this night, the unthinkable happened. One of those enactors got stuck. It got delayed. And it was holding on to a very, very old DNS plan. While it was stuck, another, much faster enactor came along, grabbed a brand new, correct plan, and applied it perfectly. And right here, this is where the race begins. Okay, here's where those two processes had their fatal collision. The fast enactor finishes its job, everything's good, and it starts its cleanup routine, deleting old, outdated plans. But at that exact moment, the slow, delayed enactor finally wakes up. It overwrites the brand new, correct plan with its ancient one. The fast enactor, totally unaware of this, just keeps cleaning up, and it proceeds to delete the very plan the slow one just applied, because according to its logic, that plan was ancient history. The result was, well, catastrophic. The active DNS record for one of AWS's most critical databases was now completely blank. To the rest of the internet, it was like DynamoDB had simply ceased to exist. Poof, it was gone. So with DynamoDB completely off the map, the real damage was just getting started. You see, countless other AWS services absolutely depend on it to function. This one failure was about to set off a massive digital domino effect. First of all was EC2. This is the service that provides all the virtual servers. It is the very backbone of the cloud. Without being able to talk to DynamoDB, it couldn't manage its own servers. So suddenly customers trying to launch new computers were being told there was insufficient capacity, no room, even though the physical servers were just sitting there, ready and waiting. Next up, the network load balancers. These things are basically the traffic cops for the internet, directing requests where they need to go. They started to fail. Their health check systems began incorrectly flagging perfectly healthy servers as unhealthy and just yanking them offline, causing connection errors to spike across the entire region. Then came Lambda, the serverless computing platform. Functions just wouldn't run. Data processing from other essential services ground to a halt. The whole engine of modern event-driven applications was just sputtering out. And it just kept going. The container services, ECS, EKS, Fargate, all started to fail. This meant businesses couldn't deploy new code or scale their applications. the entire modern software pipeline in the region was effectively frozen solid. So why was EC2 failing so badly? To get that, we need to meet a little-known system called the Droplet Workflow Manager, or DWFM for short. Its main job is to manage the physical servers, which AWS calls droplets, and it maintains a lease on them to know what they're up to. And you guessed it, that whole lease system depended on DynamoDB. So when DynamoDB finally came back online, the DWFM was just slammed. Every single server in the fleet was screaming to reestablish its lease all at once. The system entered what the official report calls a congestive collapse. It's the perfect description. It's like a citywide traffic jam where every single intersection is gridlocked. Nothing could move. No new servers could launch because the management system itself was completely paralyzed. At this point, all the automated recovery systems had failed. The cloud was broken in a way it was never designed for. And this is where the human engineers had to step in and piece by painful piece, manually put the whole thing back together. So the first big battle was just getting DynamoDB back online. It took them about an hour, but they identified the empty DNS record as the cause. By 2:25 a.m., they had the DNS info fully restored, and by 2:40, as DNS caches around the world finally updated, the service started to reappear. Step 1 was finally complete. And this quote from the report is so important. It highlights just how bad this was. The system was so fundamentally broken that all the layers of automation, all the safeguards built to handle failures, were totally useless. It took actual engineers stepping in directly to fix the core problem. Now, fixing that EC2 congestive collapse, that was even more delicate. It wasn't a simple reboot. First, they had to slam the brakes on all incoming requests just to stop the flood. Then they had to carefully restart the DWFM hosts one by one to clear the gridlock. Only then could the system slowly, methodically start to reestablish its leases and come back to life. Okay, so the fire is finally out, services are restored. What now? A failure this massive provides some invaluable, if very painful, lessons in how to build a much more robust and resilient digital world. AWS took some immediate and pretty serious steps. First, obviously, they disabled that faulty DNS automation across the globe until the race condition was permanently squashed. They're adding new controls to stop load balancers from failing so quickly, building new tests for the EC2 recovery process, and beefing up throttling to prevent another congestive collapse. Basically, they're hardening the system at every single point where it broke. But I think the biggest takeaway for all of us is seeing just how profoundly interconnected these systems truly are. We build these incredible layers of abstraction, but underneath it all, a single tiny flaw in one fundamental service can kick off a catastrophic chain reaction that takes down pretty much everything else. And that leaves us with this one final lingering question. We can patch bugs, we can add safeguards, but as our entire world becomes more and more integrated with these incredibly complex systems every single day, is it even possible to design something that's truly immune to the digital domino effect? Or is this just the price we have to pay for living in the cloud?